Storms are nature's grand theatres, where light, wind, and water perform in a tempestuous spectacle that can enchant even as it terrifies. Imagine standing at the cusp of a gathering storm. The sky broods with a heavy, ominous hue, wind howls like ancient spirits, and the air tingles with static, forewarning the impending chaos. This raw, untamed power has both a mystical allure and a stark reminder of our own fragility against nature's might. From thunderstorms to hurricanes, each storm carries its own set of characteristics and scientific intrigue. At their core, storms are vast engines powered by the basic physics of heat, moisture, and atmospheric pressure.
Thunderstorms form when warm, moist air rises in a cooler atmosphere, creating an unstable environment where water vapor condenses into heavy clouds, setting the stage for heavy rain, thunder, and lightning. These conditions often intensify over open waters, giving rise to cyclones or hurricanes, marked by their destructive wind speeds that can surpass 157 miles per hour. As these storms traverse the oceans and continents, their paths are influenced by global wind patterns and geographic features, creating a complex dance of natural forces. A subset of these, tornadoes, represent one of the most violent atmospheric phenomena. Born from severe thunderstorms, these twisting columns of air touch down on Earth with such ferocity that they can obliterate almost anything in their path. Throughout history, these natural phenomena have been observed and studied, leading to an enhanced understanding that today assists meteorologists in predicting their onset and potential impacts. The perennial challenge, however, remains the unpredictability associated with their specific paths and the severity of their impact.
The interaction between humans and storms has a long, often tragic history, marked by tales of resilience and innovation. As urban centers expand into vulnerable coastlines or storm-prone areas, the stakes have only grown higher. Historical events like Hurricane Katrina in 2005 or the more recent Cyclone Amphan in 2020 showcase the dire consequences of powerful storms hitting densely populated areas. These events emphasize not only the loss of life, but also the substantial economic impacts and long-term recovery efforts. Beyond the immediate physical damages, storms have profound social and ecological impacts, disrupting lives, habitats, and economies.
Understanding a storm requires dissecting its many layers, from its violent heart to the outer fringes where its power dissipates. A storm's life cycle begins with the calm before the storm, a deceptively peaceful phase where atmospheric conditions align for the storm's birth. As the storm matures, its center, often called the eye in the case of cyclones, forms a serene nucleus around which the most destructive winds rage. Surrounding the eye is the eye wall, where the wind speeds reach their peak and the air spirals upwards, drawing in more moisture and maintaining the cyclone's energy. The outer bands of a storm consist of clouds and showers that stretch outwards, affecting weather patterns even hundreds of miles from the storm's center. Each of these elements, from the subtle beginnings to the storm's extensive reach, involves intricate scientific principles. For instance, the Coriolis effect, a force caused by the Earth's rotation, imparts the circular motion to cyclones, differing in direction depending on the hemisphere. In dissecting a storm structure, researchers can predict its path, strength, and longevity, thus providing crucial information for weather models and emergency management strategies. This anatomy not only depicts a map of destruction but also charts the paths to mitigation and preparedness. Modern advances in meteorological technology have significantly improved storm prediction. Satellite imaging, radar technology, and computer modeling create accurate forecasts that help in executing timely evacuations and preparedness measures. Efforts are ongoing to refine these predictions, aiming to provide even more advanced warnings and thus save more lives.
Historical events like Hurricane Katrina in 2005 or the more recent Cyclone Amphan in 2020 showcase the dire consequences of powerful storms hitting densely populated areas. These events emphasize not only the loss of life, but also the substantial economic impacts and long-term recovery efforts.
In response, communities have learned to respect these natural phenomena, adopting strategies to reduce their vulnerability. This involves stringent building codes, effective evacuation plans, and investment in weather forecasting technologies.
In exploring the vivid world of storms, their unpredictable nature, and the human quest to understand and deal with them, this essay highlights the intersection between awe-inspiring natural events and the pursuit of scientific understanding and safety. Storms, while among the most dramatic and destructive of nature's productions, also offer profound lessons on coexistence and resilience in the face of monumental challenges.